IGRP, or Internet Gateway Routing Protocol, is a proprietary Cisco protocol that can only be used on Cisco routers and equipment. In several ways, IGRP is like RIP version 1. It is classful, so it does not include the subnet in its routing information. It only supports IP routing, and it cannot route discontiguous networks using VLSM, or variable length subnet masks. Also like RIP, IGRP is a distance vector protocol and uses hop count as one of its methods of routing traffic. This is where the similarities between RIP and IGRP end. Unlike RIP, IGRP uses a composite metric composed of combinations of bandwidth, delay of the line, MTU or maximum transmission unit, link reliability, and load. This is more complex than RIP's simple hop count, so it allows IGRP to take advantage of faster links where the hop count would be the same. IGRP has a lower administrative distance than RIP, 120, or Open Shortest Path First, 110, overriding both protocols with an AD of 100. The only dynamic protocol with a lower administrative distance is EIGRP, or Enhanced Interior Gateway Routing Protocol, with an AD of 90. IGRP has a much larger maximum hop count than RIP, 255. The default is 100. This makes IGRP better suited to larger networks than those that use RIP and are limited to a hop count of 15. All routers using IGRP must be within the same autonomous system and use the same autonomous system number, AS number, in order to communicate. Example: router IGRP 10 means that I'm placing this router in the autonomous system of 10. Some of IGRP's default timers include update, which is every 90 seconds and it's the interval between routing updates, invalid, which is 3 times the update timer, and that's the interval for a route to be determined as invalid, and hold down, which is 3 times the update timer plus 10, and that's the time during which routing information is suppressed. Finally, there's a flush timer, and that's 7 times the update timer, and it's the interval for a route to become invalid and be removed from the routing table. To set up IGRP, first go to privileged mode with the keyword enable, then go to global configuration mode with the config-t command, then go to router configuration mode with the command router IGRP and specify an autonomous system number, such as 444. Then you can specify networks that you wish to advertise. The last few networks we set up use 2800 series ISR routers. This time we're going to set up a network with legacy 2600 routers. First, we'll configure physical connections, IP addressing, and adjacencies. Last time we implemented routing on 2800 series routers. So this time we're going to implement routing on 2600 series, a bit more primitive. And the syntax and the structure will be a bit different, as well as the slot and port configuration. The last time we used a dynamic routing protocol, RIP, routing information protocol, it was broadcast based, it was distance vector, had a maximum hop count of 15, and it used a very simple metric, just a hop count, to determine the best path to send packets on their way from one subnet or network to another. Remember that it would broadcast the networks where it was advertising every 30 seconds, and eventually convergence time was about maybe a minute and a half, sometimes as long as 2 minutes. RIP is okay for small networks, but when networks get a little bit bigger, mid-sized to larger networks, you need a more sophisticated dynamic routing protocol than just RIP. One of the biggest problems is obviously if your hop count is 15, if that's the maximum, then any networks or subnets over that would be unreachable utilizing RIP. So another problem, I guess, would be the traffic, and also the fact that since it's such a simple metric, it's just the hop count, it doesn't take into account bandwidth. RIP might look at a connection and say, well, if I send it this way, it takes 3 hops, and if I send it that way, it takes 2 hops. So it might assume that the way that takes 2 hops is more efficient, is better. However, what if the bandwidth is 10 times as much on the route that is 3 hops, and you could experience pinhole congestion because you could have really narrow bandwidth, and RIP would be thinking that it's picking the shortest path, but really it's going to take the packets longer to get there because they have less bandwidth. So this is where IGRP comes in, the next dynamic routing protocol we'll look at. Now, unlike RIP, this is a proprietary protocol. By that we mean that you have to purchase and use Cisco equipment to use it. It belongs to Cisco. It was developed by Cisco. And the acronym stands for Interior Gateway Routing Protocol, or Internet Gateway Routing Protocol. And it is a distance vector protocol, but it uses a composite metric, unlike RIP, which uses a simple metric. The composite metric is composed of a combination of bandwidth, the delay of line, and you can also include the MTU, or maximum transmission unit, link, and reliability and load. It has a maximum hop count of 255, and the default is 100. So again, it can accommodate a great many more networks and subnets in its structure. And also, it doesn't generate as much traffic. It doesn't broadcast as often as RIP does. So it's a bit more efficient. So I guess some of the advantages and maybe disadvantages. So let's look at actually setting up IGRP and implementing it on these 2600 series routers. One more thing, IGRP uses something known as an autonomous system. And basically this is a group of routers that share routing information, alright? So neighbors and routers that would share their advertisements with one another. And so we're going to group all of these routers here, these three, we'll put them into an autonomous system, and they'll be grouped together. Just to review configuring interfaces and to highlight some of the differences between the 2600 and the 2800 series routers, we're going to also go in and configure the IP addressing on these routers. Let's make our physical connections first. So let's start at the physical layer here, and let's kind of make our connections. And I'm going to take Fast Ethernet here on this host, and I want to connect it to Fast Ethernet 00 on this router. And then I'm going to take Fast Ethernet on this host and connect it to Fast Ethernet 00 on this router. And I'm going to take port 1 here on this switch and connect it to Fast Ethernet 00 on this router. And then to connect the routers together, we're going to use serial connections. And remember that by default, Cisco routers and devices operate as DTE, data terminal equipment, but we'll need a DCE end of the connection to provide the clock speed, or the clock rate. So for clocking, I'm going to do DCE, both DCE connections on this middle router here. And that's just determined physically by the kind of adapter or connector you plug into the router. So virtually, we will do that. And this connection here will connect first, serial 00. And I'm going to make this the DCE connection. So we'll have to set the clock rate on the middle router. And I'm going to connect it to the serial interface on our perimeter router there. And I'm going to click again, and I'm going to select serial interface 01, the next serial interface, and make that DCE as well. And I'm going to connect it over here to the first serial interface of this router. Okay, so we've got our basic connection set up. Now we simply need to go in and configure our interfaces. Now let's configure each router's Fast Ethernet and serial interfaces. Configuring the first perimeter router. We'll start on the perimeter router here on this subnetwork, and notice that to serve as a gateway for network 10, it needs to be configured as 10.1. And then for the connection here, we'll do 20.1 on the serial connection. So for that first router, I'm going to log in, and I'll go to privileged mode, and from privileged mode, go to global configuration mode, and let's give it a host name, and we will call it Enterprise. I guess that's kind of nerdy too there, huh? But anyway, we'll give it a host name. And now let's go and select an interface. So I'm going to select the first interface, Fast Ethernet 00. And I'm going to select an IP address and 192.207.10.1 to serve as a gateway, and a Class C subnet mask. And as a string, I'm going to set the description. Connection to network, just be short this time, 10. And I want to use the command no shutdown, or no shut, to bring the interface up and make it active. The next interface I want to select, and this is a little bit different from a 2800 series router. Remember in the 2800 series router, it was S and then 000. Well, it's only S00 on the 2600 series router. So I'll do that. And so, slot 0, port 0, and the IP address, this is going to be 20.199.207.21. Also a Class C subnet. And description, connection to network 20. And we will also want to do no shutdown. And being the serial interface, if this were the DCE end, we'd also have to provide clocking or set the clock rate. But since it's the DTE end, we don't need to do that here, and we won't. And the only other thing we might think of, we might set some login passwords and things. And do you remember how to do that? If I exit out of here, for interface mode, notice I can select lines. So if I do line console 0, and I can say password, what was our password? We're using Kiwi, and login. And I can say line auxiliary or aux 0 and password Kiwi and login. And I can say line VTY and remember it was 1180 I think for the 2800 series, but it should be 4 for you know, in this case for the virtual terminal for VTY or Telnet on a 2600 series router. Usually defaults to 04. And then the same thing, password, Kiwi, and login. And I want to do that because remember that Telnet is disabled by default until you actually set a password. So I need to go ahead and exit, and I'll go ahead and while I'm in global configuration, but I'm gonna do one more password. I'm gonna set a global password. And remember that was enable secret and Kiwi. Okay, now that we've done that, I'm going to go ahead and hit Control Z, or I could type exit to get out. I'm going to show my running configuration, and notice there are my passwords, and there's my interface. Here are my interfaces right here. Okay, my IPs. And 192.167.21, 192.7.10.1. And the only other thing I might want to do, if I wanted to, in global configuration mode, I could say service password. Remember encryption. If I wanted to encrypt my passwords, and then to complete it, I need to show running configuration. If this were the 2800 series router, I would be able to simply say do show run, but it depends on the model. To be backwards compatible with older equipment, I'll just exit out and I'll say show run. And I have to do that in order to complete the step of hashing and encrypting my passwords. And when I do that, remember that you can go back and turn, you can say no service password encryption and turn it off. It's no longer needed once you've encrypted everything. Okay, so I just want to do copy, run, and start. Make configuration to the startup configuration. Everything is saved. And that's my first router. Now we'll do the second. Configuring the second middle router. Now let's configure our middle router. And remember that if these two are going to be the DTE ends, this has to be the DCE end. So when we configure our serial interfaces, they'll have to be set up as the data communications equipment or DCE part and provide clocking for the clock rate. So again, I'm going to log into my router, and I'm going to go to privilege mode, go to global configuration mode, and the first thing we might do is modify the host name, and we'll call it Defiant. And the next thing I may want to do is let's go ahead and give it a global password, enable secret Kiwi. That's what we're doing for everything else. I'm going to go ahead and select our first interface and go into interface configuration mode. So F00, take care of that one first. IP address, and that was network 30, so 192.168.31. It'll be the gateway. Class C subnet. And I'm going to set the description. Connection to network 30. And I want to do no shutdown. And in this case, I'm going to bring the interface up if it's down. The next thing I want to do, let me select the first serial interface here. Now that I'm in the middle router, again, I make sure I want to provide the clock rate or clocking. And what's different is the syntax is a little different. Notice that on a 2800 series router, we go 000 typically in the slot and port configuration. but it's just S0/0 with a 2600 series router. Okay, and I'm just going to do IP address. Oops. Set the IP to 199.207, and in this case, this first serial port will be 22. That'll be our connection to the other router. And Class C subnet 255.255.255.0. We'll set the description. Oops. Connection to network 20, and I want to set, this time I want to provide the clock rate, so it'll be 6400 set by default, and then just no shutdown to bring it up and make it active. And then the next interface I want to select will also need to provide clocking on, since it's the DCE connection to the next router, will be S01. Okay, and I want to specify my IP address, and it's going to be 199.207, and in this case it's going to be 41, because going out to this router it's going to be 40. Okay, so 41 and a Class C subnet mask, and description, connection to network 40, and I want to specify the clock rate, and I'm going to go ahead and use no shutdown to bring up the interface. And now that those three interfaces have been configured with IP addresses and they've been set, so I have 20, 30, and 40 networks configured, I'm going to exit out of interface configuration mode, and from global configuration mode I'm just going to set some more passwords. Remember that I can't use telnet unless I set the virtual terminal password. It's disabled by default till I set the password, so I'm going to do that. This is a little different from the 2800 series router where it would be like a 1180. Here it's 04. And I can just use the password command, and we'll make it Kiwi. I almost said Peewee. And again, trying to type and talk at the same time. Line console 0, and set the console password to be the same, and log in. We could do no login if we wanted to turn it off, but and the auxiliary line aux 0 and password Kiwi and login. And I'm going to go ahead and exit out of this mode, and let's go ahead and encrypt our passwords while we're here. Service password encryption. And remember that I have to exit out, and depending on the model you're on, from global configuration mode you could use the command do show run, but some older models of router do not support that, so a lot of times I'll just log out. But if I did do show run, notice that I can't, if I run a 2800 series router I could do that, but I can't, so let me exit out, and now I can do a show run. So there, just beware there are differences in the syntax of different models of router. What works on one doesn't always work on another. But that just kind of lets me view my configuration. So if I go up here, I can see I've got 31 on fast Ethernet, 22 on a serial connection with a clock rate set, and I have 41 on another serial connection with the clock rate set. And then my passwords have been encrypted. And then the last thing I might do is turn off no service password encryption. Don't need it once they've been encrypted. Control Z, go back down to privilege mode, and I'm just going to do copy, run start, copy my running configuration to my startup configuration to save it all. And now we're done with the middle router. You can see how our IPs work now. So 3010 has a gateway of 31, 1010 has a gateway of 10.1, 21 connects to 22. Let me move this around a little bit. And then 41 will end up connecting over here to 42. So everything looks good so far. Configuring the third perimeter router. And now we're just going to configure our last router, which is also a perimeter router on a stub network. Let's log in, and let's go ahead and go to privilege mode, And let's go ahead and go to global configuration mode, and let's do our interfaces first this time. So the first one we'll do, this time let's do the serial interface, S00, and that'll complete our connection going across the network. And I want to set the IP address, and it's going to be 199.207.42 with a class C subnet. The description would be connection to network, connection to network 40, and I want to use the no shutdown command, bring the interface up. The next thing I want to do is select my next interface, which is fast Ethernet, and again that's going to be F00 for fast Ethernet, and I want to give it an IP address, and it's going to be a gateway for the 50 network, so 199.207.50.1, and a class C subnet. And now I'm going to give it a description, connection to network 50, we'll say, and I want to use the no shutdown command. Remember, on the serial we didn't have to set the clock rate, again because it's the DTE side. If it's the DCE side, that would have been necessary. Just maybe an important note to remember. So I've got my interfaces up and they are configured, and now I can go back and set some other things. So first, the host name, let's call it the Constellation, since we're doing Star Trek themes. And let's go ahead and give it a global password. We'll call it Kiwi, why not? And let me go ahead and set some of the other passwords. So we'll do Telnet. Remember, again, Telnet's disabled until we set the password. So I want to go into line configuration mode, select the line, so VTY for virtual terminal, 0 and 4 on the 2600 series, which we're on now. Remember, if we're on the 2800 series router, it would be like 1180. So VTY04 and password and Kiwi, and specify login and line console 0 and password Kiwi and login and line auxiliary 0 and password Kiwi and login. Okay. And with all of these passwords set, let me go ahead and exit out of line configuration mode. Let's encrypt everything. So service password encryption. And remember, if this were a 2800 series router, we could just say do show run. But being a 2600 series router, that syntax won't work here. So we need to exit, drop down, and do a show run. And this completes the hashing and encryption process. If you don't do a show run, and you just turn on the encryption service, then your passwords don't actually encrypt. Interesting note maybe, but so now that they are encrypted, there's no point in using up CPU cycles and resources and memory and things. Let's turn the service off. They'll still be encrypted. So no service password encryption. Okay. And then that's everything. I'm going to do Control Z, drop back down to privilege mode, and I'm going to do copy, run start. So the running configuration to the startup configuration, and then I'll save everything. And now we have all our adjacencies and neighbors and connections set up. So we should be at the point now where we're ready to go in and set up IGRP. Finally, let's set up IGRP routing for our new network. So we're going to hop on the first router and configure IGRP. Type in our password, enable to go to privilege mode, type in our password. I'm going to go into global configuration mode, terminal configuration, config T. And now I want to go into router configuration mode for a dynamic routing protocol. And this time I'm going to do router, IGRP, and we'll set up as our autonomous system 444, which is this number that seems to stalk me over and over, so why not? IGRP 444. And then what are the networks that we want to advertise? Well, again, network, the network to advertise would be 199.207.10.0 in this case. And that's really all I need to do on this perimeter router. On the middle router, I'll take care of advertising the other, its direct adjacencies. So network 10. and I can exit now. And I just need to make sure that, this is arbitrary. I mean, I could call it 7, 13, 444, whatever I want, but I need to make sure that I put the other routers in the same autonomous system so that they will communicate with each other. Otherwise, they won't. So maybe just sort of a caveat with IGRP. Okay, and I'm going to do Control Z, go back down to privilege mode, and I'm going to say copy, run, start. And copy my running configuration to the startup configuration. And exit out. And now I want to go onto the middle router. I'm going to set up IGRP, so type in my password, enable to go to privilege mode, type in my password, config T to go to global configuration mode. I want to type in a router command, so router IGRP, and autonomous system 444. Mwah, the number haunts me. The networks I want to advertise are the direct adjacency. So let's take a peek at that real quick. You can see that it's network 20, it's network 30, and it's network 40. So those are the ones the middle router needs to advertise. So 199.207.20 and 30 and 40. Okay, and with those advertisements, or if you're British, advertisements, let's go ahead and exit. Oops, can't even exit there. Okay, and let's go ahead and save our configuration. So copy the running configuration to the start configuration, copy run start. And let's go ahead and exit. And everything's going, and now we just need to configure our last perimeter router, and we need to advertise network 50 here. So we're going to hop on and Kiwi and enable, and let's go to privilege mode. So put our password in Kiwi, config T to global configuration mode, router configuration mode, router IGRP 444, and let's advertise network 199.207.50, the one we want to advertise. And at this point we're done. Let's just copy the running configuration to the starter configuration, copy run start, save everything, and we will exit. Okay, and this time I'm going to hop on the middle router. We'll look at debugging mode, and let's look at some traffic, because we'll be getting a little bit more traffic here, beginning it from both sides, so to speak. Put my password right there. Go to privilege mode, and from privilege mode, maybe let's try some of these commands. So the first thing I'm going to do is show IP route. And notice in this case I have 3 adjacencies or direct connections prefixed with a C, but I have 2 that are prefixed with an I, and these are networks that we've learned about. I've learned about 50 and 10 via IGRP. Okay, so that's one interesting thing to examine or to look at. And let's do debug IP IGRP events. We'll see what's happening there. Debug IP IGRP events. Maybe we'll look at some of the traffic taking place here. Have to wait just a little bit. Let me pull this up too. I hope I'm not cutting that off in the video. I hope that's visible. Okay, so IGRP event debugging, and notice that the broadcast traffic, the events are much less frequent than what happens with the RIP. So IGRP it's a lot more efficient. It's not filling up our network with traffic the way that RIP does, or at least with lots and lots of broadcasts. And I'm going to go ahead and, while we're waiting, we can wait and wait and wait so long. I'm also going to do a debug IP. There you go. There, finally we got an update. Okay, so we're going to do that, and then I'm also going to turn that. Let me turn that off. Undebug all. And you can see here's our IGRP updates among neighbors in its autonomous system. Another thing we could look at is transactions. I could say debug IP IGRP transactions, and we'll just take a look at that real quick. May have to wait a while, but I know I should do stand up while we wait. Wait, you can't see me. Oh, okay. Well, I guess it isn't. I can't do jokes anyway. I always screw up the punchline. Awkward. Waiting. So, how's the weather today? Here, it's raining. What is today? For posterity's sake, this is March the 31st. The year is 2011. The day of the week is Thursday. The time is 3:26 p.m. And it is rainy. It's been storming and lightning and raining all day. April showers are about to burst upon us. Hopefully they will bring May flowers. So IGRP protocol debugging is turned on. There you go. They're sending an update. So you can just kind of see the action going on, see some of the traffic going on. And I'm just going to turn it off with undebug all. And let's go ahead and perform a test here and see how far we can get a packet. And to do that, I'm going to hop on the far side of the network, the farthest host Artemis, and I'll try to get the farthest host all the way over here, Zeus. We'll see how far we can get a packet across using our wonderful dynamic IGRP. So ping, and I'm going to do 199.207.10.1. Obviously, I should be able to hit my own gateway. If I can't do that, I'm really in trouble. Okay, so let's try to hit the other side of that. A direct adjacency at 21, no problem. Let's hit the other side of the 20 network at 22, no problem. So let's see if I can hit the adjacencies on the next router now. Let me try 31. No problem. Let's try 3010. Oop, looks like 3010. Something's going on with 3010 there. And let's see. Let's try 41. Let's do 41. No. I just haven't reached that far yet. Alright, so not 3010, not 41. And that means we're not going to be able to hit 42. There we go, 42. Alright, so now we got... There we go. So we dynamically learned our routes there. Let's do 31. And let's do 3010. There we go. Now, it just took IGRP a while for, to learn all of its neighbors' routes and things. We've got as far as here, 42. So let's try to go ahead and push it all the way to the other side of the network now. So we're going to do 51 on the other side, an adjacency on that router. And now what we're going to do, we're going to hit Zeus, right? And what is he? He's 192.0.750.13. So let's hit Zeus at 50.13. 50.13. And there we go. So it took about maybe, 2 minutes there, but finally IGRP, converged and learned all of the neighboring routes. So this has been our second dynamic routing protocol. Next we're going to take a look at EIGRP, and we'll also look at OSPF.